The champions believe in themselves, believe in their dreams, believe in their efforts, and believe in their prayers. We have dreams that will be realized with full confidence. Together with God's permission, we present an idea. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen, the honorable to the judges, supervisor, committee, and panelists. We are Pyeong team from University of North Sumatra. My name is Putri Devia Cika, SVP of Marketing and Human Resource.
My name is Intan Rahayu as President Director.
My name is Rohimah Salsabila as a VP of Finance.
My name is Aufa Khadijah as VP of Production.
With the guidance of our supervisor, Professor Dr. Insinyur Renita Manurung MT, we proudly present our idea. Biobattery from Putty and blood comes up.
As the world grows, the demand for energy continues to increase, but energy supply is still heavily dependent on depleting fossil fuels. The electricity sector plays an important role in the development of a country, but in Indonesia, the level of availability electricity is still relatively limited compared to the level of demand. Indonesia is famous for its large sugarcane production. Overall, sugarcane plantation land in Indonesia are located in Java and Sumatra. One of the sugar factories in North Sumatra is the Mayang Sugar Factory. This factory uses sugarcane as raw material for producing granulated sugar with a byproduct of about 50% cane putty which has not been used optimally. On the other, Indonesia is an island nation with vast natural riches. Vast natural riches, one of which blood can shield. In North Sumatra, precisely in the waters of the Percut estuary Deli Serdang, there is potential for blood calm shells to reach 1 to 3 pounds per day, where the processed shells produce waste that contains high calcium carbonate, so that these waste have the potential to be used of material for biobattery production to produce renewable energy innovation.
Research and analysis method. Biobattery manufacturing uses electrochemical principle using a reduction-oxidation process. This transfer of electron by electrolyte ion will produce a differences in voltage and electric current if connected or coupled with an electronic component such as diodes, resistor, or capacitor. Making biobattery from cane putty and shell is divided into 3 stages. First stage is calcination from blood cum shell. Second stage is making a paste from cane putty. Third stage is processing cane putty electrolyte paste and blood cum shell calcium into biobattery filling. Calcination, blood cum shell that have been reduced in size to obtain calcium oxide through the calcination process. Making paste, cane putty is cut into a smaller size, then weighed and finally ground using a blender to make it into a cane putty electrolyte paste, then soaking the paste with a mixture of vinegar and water and stand for 30 minutes. Biobattery filling, first removing carbon and then inserting the cane putty paste and calcium carbonate mixture into the battery stone and then close the electrolyte rod.
Responding to this problem, one of the innovations we get for the progress of Indonesia, we propose the idea of using cane putty and blood cum cells or anodara granulosa as alternative energy for biobattery. In making this biobattery, it utilizes waste from the productions of the Mayang Sugar Factory, namely cane putty and seafood restaurant waste in Bagan Percut village. Cane putty is solid waste produced for sugar factory which are abundant in Indonesia. Cane putty, including biomass containing lignous cellulose, is very likely to be used as an alternative energy source such as bioethanol or biogas. We can see that at the table 2, the components of cane putty contains about 52.7% cellulose and then 20% hemicellulose and the last is 24.2% lignin. Cane putty contains about 90% organic matter. These organic and inorganic components can function as electrolytes or substitute for the paste on the battery. This electrolyte will produce an electric current in the battery stone. The water content and caloric value of sugarcane can be seen in the table 3 as follows. In the table 3, we can see that the result of the water content test and the caloric value of sugarcane are presented. Electrical conductivity is influenced by water content. It plays a very important role in delivering the electric current that occurs in the battery due to change in chemical energy into electrical energy. And the next is blood clot cells or another granulosa have calcium carbonate, which basically has pores that have the ability to absorb other substances into the surface pores. Blood cells contain about 98.7% calcium carbonate, which is an organic substance, and the rest is magnesium carbonate and calcium phosphate. Calcium carbonate can be synthesized into calcium oxide, which is an active component as an active absorbent for toxic compounds such as cadmium metal ions and other heavy metal ions.
Feasibility and benefit of implementing ideas. Biobattery can be alternative, especially rechargeable battery stone, because they can reduce the amount of hazardous and toxic material waste. Blood calm shell potential can reach 500 until 750 tons per day in pursuit, and also 400,000 hectare sugarcane plantation in Indonesia. From the data, cane putty and blood calm shell has the potential to be used as sustainable biobattery raw material.
The parties who can help to support the implementation of this idea nationally are as follows: government, researcher, sugar factory and seafood restaurant, traders, and the community. All of these parties have their respective roles in implementing this idea. The strategic steps in realizing biobatteries from canopy and blood calm cells can be done in two stages. The first stage is to carry out a conception in which there is a formulation of policies that underline the development of this project by the central and local government. And the next stage is to manufacture a biobattery prototype and conduct tests according to the appropriate Indonesian national standards. So the best biobatteries then will be produced on a national scale, and building a biobattery factory in stage so that they are able to produce biobatteries that the needs of Indonesian people. The selling price for one piece of our biobattery is 3,200 rupiahs, and the profit earned in 1 year of production is 1,774,000 rupiahs. The social and environmental impact analysis is as follows. The first is the use of blood calm cells and care putty can support the community's economy, reduce waste that can pollute the surrounding environment, and also can support people's life. And the second is zero waste lifestyle. This biobattery is considered very sufficient to be classified as a zero waste product. So this trend provides opportunity that we will do to offer the best solution in the form of renewable energy for the community. And the next is evaluate of alternative solution. The significant effect of COVID-19 are changing many lives in the world, seeing many aspects of health and health protocols that must be applied. Research that will be carried out by researchers is the best way before carrying out biobattery production in the large scale.
One question. Biobattery from cane putty and calcium oxide from cells is a visionary idea in providing clean energy. The concept is to utilize sugar factory waste and seafood restaurant waste.
And the last is suggestion. The development of these biobatteries is also an environmental conservation measure. It can reduce the amount of waste from sugarcane and cells being disposed of into environment, and also boost the productivity of sugarcane plantation and the productivity of shellfish fishermen in Indonesia.
So that's all from our presentation. We are sorry if we made some mistakes, and also we would like to thank to Pertamina, Pertamina University, and University of North Sumatra.
Thank you for your attention dan terima kasih.
Molo songoni, mauliate, magodang.
Salam sian, nami, tano batak.
Horas Medan.
Horas Medan.